G'day, it's Richard Maher again from Mars Classes. This episode we're going to have a look at the relativistic effect of length contraction. Now most of you are familiar with this equation here, which looks at how the gamma factor impacts on the proper length when an object is moving or moving relative to an observer. So we know that the length contracts but the height doesn't. In this episode we're going to have a look at not only the length contraction but what happens to the distance through which an object travels. So in this instance, we're going to have an imaginary situation where there are two planets, which are 2 light years apart. They are joined by 2 rods. One is a purple rod, which is 1 light year long, and the other is an orange rod, which is 1 light year long. There's a rocket that is halfway between the 2 planets and is going to be moving toward planet C. Now, if the rocket moves toward planet C, we're now going to consider what different observers will observe the length of that rocket to be. So I'm going to pose a few questions. What will the observer on planet C see as the length of the rocket ship be? As it moves toward it, because we know that it is moving relative to it, its length as observed by the observer on planet C will be shorter. If we're looking at an observer which is actually within the rocket, when they're within the rocket, relative to them, the rocket is not moving. So what would be the length of the rocket as observed by the observer within the rocket? Well, it's going to be the same length as it always was, the same length as the proper length. If there is an observer on planet A and they're observing the rocket as it moves away from it toward planet C, well, relative to planet A, the rocket is moving, so its length will be appearing shorter. If we look, however, at the length of the rods, now the length of the orange rod relative to the person on planet C, that orange rod has not moved at all. So when the person on planet C looks at the orange rod, it is still 1 light year in length. So its length will still be the same as it normally was. The same goes for the purple rod when observed from planet A. Because it's not moved relative to it, its length will still be 1 light year. It'll be the same length as its proper length. However, when we look at an observer in rocket B, how will they observe the lengths of these rods? Now, I'm going to tell you that the lengths of the rods as observed by a person on rocket ship B will be shorter than what the proper length of them is. How can we explain that? One way to do that is to consider the same situation we saw before, but this time, rather than saying the rocket moves towards planet C, let's say planet A, the purple rod, the orange rod, and planet C all move relative to the rocket. Now, when that occurs, when we look at all those same scenarios, I challenge you to see common sense tells you exactly the same thing. So when you get down to the bottom one and you see what will an observer on rocket ship B see the length of the rods as, because the rod is now moving relative to the rocket, the observer on rocket ship B will see that the length of the rod is now shorter than its proper length. So the people on rocket B will think they're travelling through a shorter distance. I hope that makes sense. And the thing is, whenever you look at relativistic effects, you've got to go with your gut feeling and say, does it make sense? All of this makes perfect sense. Okay, I will be giving some more episodes to do with relativity coming up. Any questions, post them below and I'll be sure to answer them.